we've moved on to item 2. Out of the 100 items you have to do, you're on item 2. So in item 2, we have a certain city experiencing social challenges with 2 distinct population groups having different experiences of urban life. The city planners are trying to understand if there is a common problem affecting both groups. They are modeling the well-being of 2 groups using 2 separate quadratic equations. This is the first quadratic equation, where P represents access to social services and Q represents employment opportunities. Then we have the second equation. This one is dealing with collective well-being, where M represents education attainment and healthcare access. K represents safety, quality. K represents safety, quality. Then the social challenge exists if Q minus K squared is equal to M minus P into PK minus MQ. So the task is, as a data analyst, identify whether the common social challenge exists or not. This one is a proof number from our old curriculum. They used to give us proof that this is equal to that, given that these 2 equations are provided in the question. So whatever they have been narrating is not necessary. Just understand where the question is coming from. It's a proof number. So in this number we have our summary here. We have x squared plus px plus q, equating it to 0. I'll call this one my expression 1. Then the second is x squared minus plus mx plus k equal to 0. This is the second expression. Then they are telling us to prove that q minus k squared is equal to m minus p into pk minus mq. So in this number, we shall begin from what they have given us. We shall not use that part of that kind of proving where we say left hand side is equal to right hand side. No. We shall begin from known to unknown. So that one is our summary. I'm going to start with trying to manipulate this. How am I going to obtain q minus k? When you look at equation 1 and equation 2, I can say equation 1 minus equation 2, such that I get this q minus k. So it's going to be, when I subtract this minus this, it's a 0. I'm going to remain with p x minus mx, px minus mx plus q minus k. And this is going to be 0 minus 0. You get a 0 there. So that's what we have. I've obtained my q minus k. I will make it to the subject straight away. So it's going to end up giving us q minus k is equal to mx minus px. But where we are going, so you have to be moving while checking on where you're going. This is where we have to be moving towards. What we do, try to look, is there x in our final equation? It's not there. So I'm going to first try to eliminate that x. Find ways of removing this x. First factorize it out. Remain with m minus p. Later on, try to move this side, so divide by m minus p, divide by m minus p. So it's going to be q minus k, divide by m minus p is equal to x. So we first leave this here. Then we move on to the next part, which is I'm going to extract this part here. I'm going to extract out this moment when I had not yet divided. It's the very moment I'm going to use down here. Why? Because I have q minus k squared. So q minus k squared is similar to x squared into m minus p squared, like that. So when you have this, try to look for x squared. How am I going to substitute this x squared from the equations that we're having? The equations that we have, 1 and 2. I can make 1 the subject. I can make x squared at this point the subject by moving these two this way. When I move those two that way, it's going to end up giving me, it's going to end up giving us this. It's going to be x squared equal to negative px minus q. That's the value of x squared from up here, from our summary here. Negative x minus q. So I'm going to replace this negative, this x squared there. So it's going to be q minus k squared is equal to negative p x minus q into m minus p squared. That is it. Then where we are going, there is no x. In this expression, we don't have any x. So I have to look for ways of substituting this x and eliminating it. So q minus k squared is equal to, what we do, we have x here. I'm going to get this x and fill it there. So it's going to be negative p. The x is going to be, our x is going to be negative, it's going to be q minus p out of m minus p. So q minus k divided by m minus p. Then we subtract q into m minus p squared. What does this give us? It's going to give us q minus k squared equal to, open those brackets, we end up with negative pq plus pk divided by m minus p minus q, m minus p squared, like that. So it's going to be q minus k squared is equal to, when I make this a fraction, it's going to be q divided by 1, and then I cross multiply. I'll multiply that up and I multiply this with q. Later I multiply the denominators, so it's going to come out in this format. 1 minus that whole system is going to be negative pq plus pk, then negative q times m minus p, end up with negative qm positive pq divided by m minus p into m minus p squared. So are you saying that this is going to move out? When I cancel this with 1 square, I end up with m minus p. So it's going to be q minus k is equal to, when you look at negative pq and positive pq, they are going to cancel, and we shall end up with pk minus qm into m minus p squared. So I think this is what they wanted. This is what they wanted. Maybe if we try to rearrange it, it's going to be q minus k squared is equal to m minus, oh, the square is not there, m minus p, then pk minus mq as required. So that was item 1. So this is item 2. Next will be item 3. Next is going to be item 3.